Section 8.3, Zeros of a polynomial in Python. In this section, we'll implement a Python code for zeros of a polynomial and compare it with a Matlab code. Let's begin with recalling how to find the zeros of a polynomial. And we studied it earlier. When the Newton's method is used for finding an approximation of a zero of a px, then the iteration can be formulated in this way. The new point is from old one. We try to get the correction term and correct it to get a better approximation. Now we have to find the evaluate p at a point and its derivative at the same point in each iteration. Now to find the derivative value, we may try to use Horner's method here. Okay, once we write this, the given p of x in this way by using the remainder theorem, then its derivative can be this one. And once we use evaluate at x0, then this term will disappear, and that is q at x0. So that at x0, the function value, the polynomial value is px0, and then now p prime at x0 is the same as the value evaluated with the quotient. So by using the Horner's method, we can get these two values at the same position x0. Here, the p of x is given in this way, and use the Newton's method and the Horner's method to implement a code and find an approximate zero of p near 3. Okay. First, let's try to find the solution, and by using built-in functions. And here numpy, and we define the coefficients. We collect here the coefficient, and now by using here the poly 1D, by using the coefficients, we can construct the polynomial, and here we can get polynomial derivative. That symbolically, if we see that is the polynomial, that is the derivative, and now by using roots, the method, we can get roots of that. So here, these are roots, and at 3, the polynomial value and its derivative value are here. Okay. Now, in this section, we'll see Python programming is as easy and simple as MATLAB programming. Particularly, NumPy is developed for MATLAB-like implementation with enhanced convenience. NumPy is used extensively in most of scientific Python packages, including SciPy, Pandas, Matplotlib, and Scikit-learn, and basically most of scientific Python packages use NumPy. But NumPy is developed for MATLAB-like implementation. So once you understand the MATLAB, then the Python is quite easy to understand. Now we implement a code in Python for Newton-Horner method to find a numerical zero of p near 3. Well, this is Horner in Python. That is docstring, and here we try to count the numbers in array A, that is the coefficients. And here now we assign the first one in the array for P, and D is 0, and this loop. After finishing this loop, and P is the function value at x0, and that is derivative value at x0. You learned this one earlier. And now Newton-Horner is given here. Start with x0, so it's x. Now, by using the correct value, using Horner method, we get the polynomial value and its derivative value. And that is the correction term h, and correction term is added to get updated the value. And once the correction term is bounded by given tolerance, then we stop the iteration and here return and the final value x, and here we count the number of iterations and its output to see how many iterations are performed. Okay, here now the coefficients is collected, and the initial point is 3, and tolerance is 10 to the minus 12, and maximum possible iteration is 1000. We call Newton-Horner, and these two are the value returned, and we print out Newton-Horner and x0 and final answer, and in the number of iterations. Okay, so we call now the function Python file, then and the result from here is now x0 is 3, and the final answer is 2 in 7 iterations. The Newton-Horner algorithm converged in 7 iterations, so to get the value. And earlier we tried to find the roots. Here these are now part of roots are complex valued, so that here the remaining part is also produced along with complex value form, but that is basically 2 and minus 0.27. There's 2 real valued solutions and 2 complex valued solutions. Okay, so we found the one of the root 2. Now the Python code must be compared with the Matlab code we used in a section earlier. There's Horner is defined in this way. That loop is exactly the same as in Python, so you can compare. And also Newton-Horner is the same. In each iteration, we call Horner using the coefficients and the current x value, and we produce P and D, and there is correction term and added. Once the correction term in modulus is bounded by tolerance, then we break the iteration and return here x and the number of iteration performed. And we call the Newton-Horner separately. A is defined. Now this is ascending order, and because we implemented in that way. Now the same way, x0 is 3, the tolerance is 10 to the minus 12, and maximum possible iteration is 1000, and we call Newton-Horner. Then after getting this one, same way, we try to print out, then the result is exactly same. Newton-Horner, and start with 3 and convert it to 2 in 7 iterations. You can compare Matlab code and Python code, but you can see big similarity. So you can easily use Python once you understand Matlab. Okay, that's it for the section. Thank you.